Hi, Assalamualaikum and a very good day to everyone. So today we want to present to you our case study for assignment IM18560 Vector Calculus, which focus on line integral. Our title of our case study is Drone Surveying Mission.
Assalamualaikum and hi everyone. My name is Awatif Auni binti Zamri. My student ID is 2023305213.
Assalamualaikum and hello everyone. My name is Fatin Ruzana binti Shahrun Zaidi and my ID number is 2023392989. To begin, let's review the concept of line integral. There are three types, which is FDS, PDX plus QDY plus RDZ, and lastly F.dr. Our case study specifically cover the first and third type. In type 1 FDS, ds represent the arc length of piecewise moved curve C. In the plane, we define C as RT equal to XTI plus YTJ for T0 to T1. After differentiate, we get R prime T equal to X prime Ti plus Y prime Tj. The magnitude is square root of X prime square plus Y prime square, and thus ds equal to magnitude of R prime T dt. We then integrate from T0 to T1 fx t yt multiplied by magnitude of RT dt. In 3-dimensional space, we let C as RT equal to XTI plus YTJ plus ZTK. The differentiation is R prime T equal to X prime Ti plus Y prime Tj plus Z prime Tk, and the magnitude can be found by square root of X prime square plus Y prime square plus Z prime square. The integral is from T0 to T1 of fxtytzt multiplied by magnitude of R prime T dt. Our case study involved a drone surveying mission with two objectives, which is forest surveillance for anomalies detection and data collection for a replanting project. This mission helped monitor deforestation, detect illegal logging, and assess replanting success. For the first mission, the drone followed two paths. It first traces the upper half of a unit circle C1 from point P60 to point Q-60, and then flies horizontally along a line segment C2 from -60 back to P60. We analyze the energy expenditure using integration of C x square plus y square ds with x square plus y square equal to 36. To calculate this, we start with C1. The parameterization is RT equal to 6 cos Ti plus 6 sin Tj for 0 to pi. After differentiating, we got -6 sin Ti plus 6 cos Tj, and the magnitude we get 6. Thus, after integral over C1 from 0 to pi of 36 multiplied by 6 dt, and the answer will be equal to 216 pi. For C2, the parameterization is 1 minus t multiplied by -60 plus t multiplied by 60 will be equal to -6 plus 12 dti. After differentiate, we got 12i, and the magnitude we got 12. After integral over C2 from 0 to 1 of 12t minus 6 square multiplied by 12 dt will be equal to 144. Therefore, the total energy expenditure is 216 pi plus 144. We can verify our result using Maple software. We define the parameterization for C1 and C2, set up the integrands, and perform the integration over both curves. The software result match our manual calculation, confirming the total energy expenditure is 216 pi plus 144.
We continue with FDR. The line integral of a vector field F across a curve C is defined as FDR. When F is a force field, FDR is the work done by F in moving an object along the curve C. And then, when F is a velocity field, FDR is the acceleration of the field across the curve C. So, how to find FDR? Firstly, let fxy equal to pxyi plus qxyj be a vector field in curve. RT equal to xti plus ytj is a curve in plane. Then differentiate R and get dr equal to dxi plus dyj. Next, integrate the f dot dr and simplify, can get integrate p dx plus q dy. For the case study for FDR will be the data collection for replanting project. The drone is fly over a forest area to gather data points while surveying a specific region where replanting project happened. During its flight, the drone follows a designated flight path, which includes straight line segment and a curved trajectory as part of the surveying requirements. The wind in the area is at a force field on the drone, described by fxy equal to x squared yi plus 1 plus 2yj. The drone's path C is composed of the following segments. First, a straight line segment from 0, -3 to -2, -3. Second, a curved path along the parabola y equal to -x squared minus 3 from x equal to -2 to x equal to 2x, and another straight line segment from 2, -7 to its final destination for -1. To assess the energy consumption and work done by the wind on the drone along its path, we'll evaluate the line integrate f.dr. The graph will be like this. So, how the calculation will be? We find separately first. We find for a straight line segment 0, -3 to -2, -3. Find R first and we get -2t I minus 3j. Differentiate R, then f.dr. Substitute x equal to -2t and y equal to -3. Then integrate f.dr and we get equal to 8. Next, we find a curved path along the parabola y equal to -x squared minus 3 from x equal to -2 to x equal to 2x. Firstly, let x equal to t and y will be -t squared minus 3 and we'll get r. Find the r, f.dr. Substitute x and y and then find integration of f.dr and we get -144 over 5. Lastly, find for another straight line segment from 2, -7 to its final destination for -1 and we get 314 over 3. And lastly, total all line integral C1, C2 and C3, the final answer will get -1882 over 15. For the mapper command, firstly define the vector field. Next, define for line segment 1, 2 and 3. Lastly, total all line integral and we get the answer. In summary, our drone surveying mission applied vector calculus, especially line integrals, to real-world forest monitoring tasks. The first mission calculate the energy expenditure of the drone as it follows a path over the forest, resulting in a total value of 216 pi plus 144. The second mission assessed the work done by wind force on the drone along a complex path, yielding a total work done of -1882 over 15. This project demonstrates the practical use of mathematical concepts to solve real-world problems in environmental monitoring and drone operations. That's all from us. Thank you.